In this video, let's take a look at triangle possibilities, the ambiguous case. If two sides and one opposite angle are given, three possible situations can occur. You can have no triangle, one triangle, or two distinct triangles that exist. In problem number 1, it says use the law of cosines to solve for angle measure x and explain your findings. So I've written down one of the versions of the law of cosines, and I'm going to go ahead and label my triangle based on this law of cosines. So if I'm looking for angle A, I'm going to go ahead and identify that as A. That means little a is going to be across. And then B and C don't really matter, so I'll just go ahead and identify B as 5 and C as 8. Let's go ahead and make some substitutions into the formula and then solve for our angle. All right, so this is going to be 2 squared is equal to 5 squared plus 8 squared. And I always recommend labeling just so you don't mix up your numbers. 4 is equal to 25 plus 64. 64 and 25. I believe that's what, 89. I'm going to go ahead and make that change right there. So that's 89. 2 times 5 is 10 times 8 is 80. Okay, now you cannot subtract these two because 80 is being multiplied by cosine of A. Now I can subtract 89 to the other side of the equation, and so 4 minus 89, that's negative 85. Divide both sides by the negative 80, and cosine of A is equal to 85 over 80. So any question about this guy? Well, let's go ahead and keep working. Maybe you don't see it. So let's go ahead and undo cosine with inverse cosine. Can you have, okay, so this is saying what angle has a cosine value greater than 1? 85 over 80 is greater than 1. Well, cosine is not defined for values greater than 1. So this is going to give you an undefined. Now let's just go ahead and test that or plug that into Desmos so that we can actually see it. So inverse cosine of 85 over 80. All right, so if I come over here, inverse cosine, cosine raised to the negative 1, 85 divided by 80, and that's giving me undefined. I'm just going to make sure I'm in degree mode, so that's correct. It is undefined because cosine is not defined for values greater than 1. All right, think back to your geometry days, and there was a theorem called the triangle inequality theorem, which stated that the sum of the two shorter legs of a triangle always is greater than the third side. And so in this case, the two shorter legs are the 2 and the 5. The sum of the two shorter legs has to be greater than the third side, otherwise the triangle does not exist. So in this case, 2 plus 5 is not greater than 8. So this triangle does not exist. You can put those lengths on this triangle, but this is not going to make a real triangle. The figure below uses a coordinate grid to show part of triangle ABC such that the measure of angle A is 30. So that's this guy right here. AB is 6 units. That's this length. These circles are just indicating a unit. So if you count from A to B, this would be 6 units. 1, 2, 3, 4, 5, 6. Side BC could have many possible lengths, but to keep the 30-degree angle, point C must fall on the x-axis. So our point C must land on this x-axis somewhere. We've got to decide where. In problem number 2, it says if BC is 6 units, then the triangle has only one solution. So we want to go from B to C and land on the x-axis and be 6 units. So let's count. 1, 2, 3, 4, 5, 6. I need to land right here. That's going to make it 6 units from B. I'm going to go ahead and draw that in. I know this is 6 units. This creates an isosceles triangle because those two sides are the same. That means this angle is also 30 degrees. Isosceles triangles have congruent base angles. All right, so estimate the coordinate of point C. It's somewhere between 10 and 11. We can say maybe 10.11 I don't know, I think it's a little bit, maybe 10.3 comma 0. We're just estimating, so that's fine. Determine the measure of angle C, and I'm going to say that that's 30 degrees. Again, because that's an isosceles triangle. Problem number 3, if BC is 4, then the triangle has 2 solutions. All right, so where do we want to put C so that BC is 4? I'm going to put it right here. Now, is that what you estimated? Most students don't pick this the first time, and that's okay. This is one possible triangle. This side length is 4 units. It's landing on the x-axis. Now, the most common choice is this guy right here, which is also 4 units. And so I'm going to go ahead and like highlight this guy in purple so that we can see this would be our second option for C. So we can have C right here, or we can have C right here. So it says estimate the coordinates for both possible possibilities for point C. So C can be at, I don't know, what is that, about 7.9? And then C can also be about maybe 2.5. And we're just estimating, so it's fine. Now, part B says use the law of sines to find both possible measures for angle C in this situation. All right, so our law of sines, sine of C over C is equal to be sine of A over A. All right, let's make some substitutions. So sine of C over little c. No matter what, little c is going to be 6. If we go across from C, from either of those angles, it's going to be 6. Sine of A, angle A is 30 degrees. And little a, no matter which side we go with, it's always going to be 4. All right, so now we just need to figure out what sine of C is. If I multiply both sides by 6, I'm going to have sine C is equal to 6 times sine of 30 over 4. Now the y value at 30 is 1/2. 6 times a half is 3. So this is sine C is equal to 3/4. Let's undo sine with inverse. And we'll take this to Desmos. Okay, so inverse sine (3/4), and that gives us about 48.6 degrees. Okay, so if I'm given 48.6 degrees, let me go ahead and clean this up just a bit. Now I can look at this triangle and identify exactly which angle it's looking for, or it's, since we have the two options, right? Is it talking about this angle here or this angle here? Well, 48.6 is an acute angle, so I'm going to go with this one right here. But now, how do we figure out what the obtuse angle would be? Well, hopefully you recognize that you have yet a third triangle, which is an isosceles right here. And if these sides are congruent, that means this base angle is also going to be 48.6 degrees. Okay, so we have an isosceles. Base angles are 48.6. I can find the supplement of 48.6 to find the obtuse angle. And the supplement is just the difference from 180. So 180 minus 48.6. And that's 131.4. So our other option for C is 131.4 degrees. Now, we have two very distinct different angle C's. We know both angle A's are 30 degrees in both triangles. We know both angle C's. Let's go with the acute angle is the 48.6 and the obtuse angle is the 131.4. Can you figure out what angle B is? Well, absolutely. You would add these together, subtract from 180 to find that third angle. And then once you have the three angles, you're able to figure out what that third side is. So let's see, 48.6 and 30. And that's 101.4. And let's see what that would be, 161.4, so 180. And how about 18.6? And so we're able to figure out the three angles of those two distinct triangles. In problem number 4, this time BC is 3 units. The triangle only has one solution. All right, so show the triangle on the figure below. So 3 units from B. So that can only land about right here. 1, 2, 3 units. Now 3 is half of 6, and this is a 30 degree. Think about your special right triangles, your 30, 60, 90. Remember, across from the 30, that's x. Across from the 60, that's x root 3. And across from the 90 is 2x. And that's exactly what we've got here. We know that the x value is 3. And we know that across from the 90, we have twice the x value is 6. So we know that this guy is going to hit at a right angle. The coordinate of C, well, across from the 60 would be the x root 3. So x root 3 is about 3 roots 3. So we could say 3 roots 3 comma 0. Now, I don't know what 3 roots 3 approximates. I hope it's around 5. Let's go ahead and check it. 3 square roots 3, yep, about 5.2. And so this is approximately 5.2 comma 0. And that's what we estimated it to be. Determine the measure of angle C. We know that's going to be a 90 degree. Okay, one last problem, number 5. Explain why if BC is 2. BC is 2. That means I'm going to stop 2 units from B. Is there anywhere 2 units from B that's going to connect to the x-axis? No, this is not going to work. Okay, so it does ask us to verify using the law of sines. So sine of C over C, sine of A over A. Okay, so sine of C and little c, well, that's going to be 2. Sine of 30 over, oops, no, I'm sorry, that's not 2. How about 6? And then sine of A, and this is going to be 2. All right, so let's solve for sine of C. Multiply both sides by 6. So sine of C is equal to sine of 30 times 6 divided by 2. So the y value at 30 is half. Half of 6 is 3. So sine of C is equal to 3 over 2. All right, let's take the, whoops, don't know what's going on there. Inverse sine on both sides. I don't know what I did, that little negative C. How about negative 1? Okay, now again, look at this number. Is y defined for values greater than 1? No. Our sine value, 3 over 2, this is going to give us an undefined. Okay, so let's, again, just take a look at Desmos, inverse sine of 3 over 2. And undefined.